Okay, everyone, this is Mr. Harding again, going to Unit 2. I am going to, just like I did with the Unit 1 review, go through every question. I may go a little bit faster this review just because this is definitely going to be the longest review. It has significantly more questions than any other review, and a lot of the questions are very similar, so I might go quick. Again, as I said in the first video, if you still need more help, you need to talk to your teacher. This video is not expected to teach you everything. It's not a cram session or things like that. This is supposed to just help reinforce. It's definitely an answer key. I'm going to go step by step through each question, but I might go quickly. So again, if you need extra help, definitely talk to your teacher. Don't rely on this video. However, Unit 2, number 1, okay, we began this unit learning about rate of change. Rate of change is also known as slope, which is the variable m, rise over run, right? We talked about it so many different ways. Y over x, that's slope, rate of change. This is where you see it most often in word problems, which is the next unit, which, by the way, I might as well tell you now, there is no Unit 3 review video because it is a very quick unit and it is focused on all of the same content, just word problems. So you'll see this phrase a lot next unit, or maybe even just the word rate. But every single time you hear that word rate, you should immediately think, at least in algebra classes, you should immediately think of the word slope. So, find the slope on the line given below. Lots of different ways to do this. I think the easiest, find a place on the graph where it definitely crosses. Find another place on the graph where it definitely crosses. It looks like right here would be 1, right here would be 1, right here would be 1. Right? You don't need all these points that I'm making. You just want to find definitely another place where it crosses and count from one point to the next, using that rise over run. Go up 1, so we rised 2, went up 1, up another 1, so that's up 2, to the right 1. Remember, going up is positive y direction, so that's a positive 2. Going to the right is positive x direction, so that's a positive 1. Positive over a positive is a positive number, so our slope there would be 2. Number 3, easy question. Find the slope of that line. Recognize that this is in slope-intercept form. Slope is the value in front of your variable x. Slope would be -4. Last one on this page, find the slope of this line. Not as easy as that question. That's because this line is in standard form, so I've got to do a little bit of work here. I've got to take this over to the other side. So let's take that x over to the other side so I can start to get y by itself. This is why we spent time working on literal equations last chapter. And then here's where you can treat this question a little bit differently. You don't need to do all of the math. Your focus is right here. And so when I go to divide by the 6, yes, I would divide everything by 6, but this is what I'm focused on. What is that going to end up being? Well, a -2 divided by 6 is a -1/3. That would be the value in front of x. That means -1/3 would be my slope. Continuing to find slope. Number 5. What is the slope of the line x equals -1? Hopefully you remember when x equals -1, that means I'm looking at a vertical line. Well, a vertical line doesn't have a slope. It is undefined, okay? So just keep that in mind. That's how you're able to answer that question. While we're here, we'll talk about this, right? If y equals a number, that's when you have a horizontal line. When you have both an x and a y equal to some number, that's when you start to get those diagonal lines, okay? 3 types of lines we talk in this class. Vertical, horizontal, diagonal. Diagonal has both variables. Horizontal has y, vertical has x. All right, number 6. That's all about using your slope formula. So a lot of you are so used to this that you have it memorized just like myself. If not, you should always have access to this. This is something that your teachers might want you to memorize, but you really don't need to have it memorized because, again, we always have access to this formula. So what I mean by y2 minus y1, when you label a point, remember it's x comma y, but when you have 2 points, we'll label this point 1 and this point 2. So that's where the 2's come from and the 1's come from. So my y2 here would be 4 minus my y1, which would be a 3. My x2 would be a 6 minus my x1, which would be a 2. And I go through with that work. 4 minus 3 is 1. 6 minus 2 is 4. And I find my slope. Seven, again, same question as 6. A little bit easier because it's multiple choice. So I go through with my formula again. Here's where I'm going to start to save time. I'm not writing that out every time. You know what the slope formula is. I'm going right into it. So we've got 4 minus, it's a negative 10, so that gives us that double negative sign, which we'll talk about in a second. 7 minus 3. Remember, when you get that double negative, right, when you subtract a negative number, that's like adding that number. So 4 plus 10 is a 14 over 7 minus 3, which is 4. Look at this. I don't have any 14 over 4s over here. That's because this needs to be reduced. Always reduce your slope. Always, always. And not even slope. Reduce all fractions. Always reduce your fractions. Number 8, kind of silly question. You don't really write much in math, but next we talked about 3 different forms. We kind of already talked about them here. These forms are called slope, intercept. It's not y-intercept. Don't call it y-intercept form. I hear that all the time. Slope intercept form, which looks like this. We have standard form, which looks like this. And we have point slope form, which is not commonly used, but and if you had me, you know I like using it, but it's not commonly used, but I think it's a very useful formula. Okay, you can easily see the point and a slope. All right, moving on. Number 9. The equation has a y-intercept of -5 and a slope. You have a y-intercept and a slope, hence slope-intercept form. So immediately I'm thinking like this. And I know m is my slope, and I know b is my y-intercept. So which one of these has the y equals -1/2? Well, definitely not C or D. Y-intercept's -5. Got my answer. Doesn't get easier than that. Don't overthink. Some of these questions really, really easy. At what point does that line cross the y-axis? Think about this, guys. You got your line. Diagonal lines are going to cross the y-axis exactly once. Horizontal lines will cross the y-axis exactly once. Vertical lines might not cross the y-axis. You know this is a diagonal line because it's got a y and an x. You also know where it starts, and you know what the slope is. So you got a rough sketch, right? Where does it cross the y-axis? Well, the y-axis is where its y-intercept is. So that would be at 0, 1. Right? Y-intercepts always have an x value of 0 because the y-axis goes up and down. X is always 0 there. In slope-intercept form, write this equation. Start out with y equals, do we know what m is? Yes. X, do we know what the y-intercept is? Yes. Easy question. Don't overthink some of these easy questions. Number 12, a line passes through the point and has a slope. So what I don't know and what I need to find based on my answers is what is the y-intercept. Couple different ways to do this. I think the easiest is to just do it very methodically. Use your formula, plug in what you know. Well, you definitely know what m is. Something that students don't always realize is you do know what x and what y are. What you don't know in this question is you don't know what b is. And that's what you're trying to find. Remember, this line any of these lines have infinitely many points on them. If I know it passes through that point, I know this point is on the line, and if a point is on the line, that means I can plug it in and I will get an equation with a true statement, which is what allows me to solve for something I'm not sure of. So the 2's are going to cancel with each other. I can subtract the 9 to the other side. I get a -5 for B, which means my y-intercept's a -5, which means it's not A and it's not C. And my slope, I kind of have something written over it here, but it was a positive slope, which means my answer is letter D. Moving right along, we are 1/3 the way through. There are 36 questions. Big review. This is a big unit. This is a very important unit. Honestly, I think the two most important units in algebra is one you will do in the second marking period and one you will do in the first marking period. And this is the one in the first marking period. Very important. How to write lines, slopes, equations, domain and range. For those of you looking into a pre-calc class, domain and range is big. So this is a big unit. Once again, recognize what I'm supposed to do. I have a slope, I have a point. So this was the exact same thing as number 12, except it's not multiple choice. Start with what you know. I know what M is. I know what X is. I know what Y is. That gives me this formula, or rather equation. Now I can solve this. Multiply those together. This is why we solved so many equations last chapter. Add that 6 to the other side. I find out what the y-intercept is. And now I can write my final answer. Y equals slope times x plus my y-intercept. Alright, write the equation in a line. Doesn't specify what form, but what I notice is all of my forms are slope, intercept, and I've got 2 points. So let's start by finding the slope. Can't go much places without slope. See, we got that double negative again, so just always watch out for that. Use your calculator if you need to reduce slopes. So I get a slope which is positive 5/3, so it's not A, it's not B. But the difference between C and D is the y-intercept, so I'm going to have to take all this knowledge and go back to what I did in number 12 and 11. And so what you can choose for 12 and 11 is you can use either number. The reason why you can use either point is because both of these are on the line. The line passes through. I like to use points that are all positive. I don't like negative numbers. I know you guys don't like negative numbers, so that's how I typically decide what point to use. It doesn't mean that you can't use the other point. It's just my preference. I'm sure everybody else has a preference as well. When I multiply these together, I'll get a 10, which I would then subtract to the other side, and that's going to tell me that my y-intercept is a 6, which means my answer has to be letter D. And 15, we're still in slope-intercept form. It looks for the final time here. I'm doing the same thing as 14, except I don't have the answers for me. I have to find the answer on my own. So same thing. Let's start with the slope. Should get your slope of a -6. Now let's work backwards. I like to use points that are all positive. I'm going to use my formula. I'm going to plug in what I know. I know what y is. I know what m is. I know what x is. I'm trying to find b. Multiply these together. Add it to the other side to get b by itself. I find my y-intercept. I have my slope. That means I can write slope-intercept form. Alright, so we're switching gears now. Now we're going at point slope form. You need 2 things. Point, slope. Look at number 16. We have a point, we have a slope. We're good to go. Here's our base formula. The x1 and y1 are the x and y values of the point. I know, of course, what m is, so I just use my formula. Y minus, what is the y value of my point? 6, equals m, 3 over 4, parentheses, x minus the x value of my point. Good to go. Easy peasy. Don't think point-slope form's hard. You got a point and a slope, but you're good to go. So what that means for a question like number 17, if you need a point and a slope, and you have 2 points, first thing you got to do, find the slope. So use your slope formula. You get it to be 13 over 26, which reduces nicely. Slope is 1/2. Now here, you can use either point, because both points are on the line. Once again, I like using the positive point. Just makes things a lot easier. What's the y value? 7 equals m times x minus, what's the x value? 20. I just think it's so much easier to use the all positive point, if there is one. Sometimes there isn't. The reason why, though, is because, so first of all, that's not your only answer. You could have used this point up here, but look what happens when I use that one. Y minus the y value of my point equals m times x minus the x value of my point. Look at this, you got those double negatives again, which you definitely have to simplify. Don't ever leave an answer looking like that. So I just have extra work to do. It's not any work that I think anybody would get wrong. It's just more work. I love using positive points. It just makes your life a lot easier. Either of those would work, though. All right, this is our halfway point. We're starting standard form. Standard form, you can't use without slope intercept, which means, yes, these questions take a long time to do. It's just the nature of the question. You need to write it like this first, and now I can change it into standard form. The way I'm going to change it is, what you notice in standard form is x and y are on the same side, right? Right now, x and y are on opposite sides, so let's get them together. Let's add this over to the other side. Now they're together, but you have to remember a couple other things with standard form. There's some rules. I like to tell people standard forms like writing your name the proper way. First letter has to be capitalized. You know, there's people that write names like this, but it's not official. This is standard form. It's an official way to write this, right? That's got to be a capital L. Okay? So, this is not official. We don't like fractions. I got to get rid of that. Easiest way to get rid of a fraction, multiply by the denominator. They'll cancel. It'll leave you with a 5x, which is perfect. That's what I need. I need a positive whole number. Now I can multiply everything else by that 6. Y times 6, because I can't just multiply the fraction by 6. Right? I got to multiply everything by 6. And now I have an equation that's in standard form. So we get to a question like 19, which is a lot of work because I've got to go to slope-intercept first. But I don't have the y-intercept, nor do I have the slope. So let's start by finding the slope, which is, kind of ugly. We get a fraction. I like to use the all positive point. So 7 equals 1/3 x plus b. Here's the next worst part. Look at this. We've got an ugly fraction here, which I got to subtract to the other side. I got to subtract that to the other side. Now I get b finally by itself, but I've got an ugly fraction coming up here. 7 in terms of thirds is 21/3. I'm a big fraction guy. I like to use fractions rather than my calculator. So I end up getting 10/3. Just use your calculator if you need to. Use your calculator for this. 7 minus 11/3 if you need to. Okay? But I promise you, you'll get 10/3. And now I can rewrite this in slope-intercept form, which is great, except that's not what I'm supposed to do. I'm supposed to write this in standard form. So we've got to take this over to the other side. Now I finally have it written the way it should with the x and the y together, but it's not proper. This number has to be positive, which it's not, and we can't have a fraction. So now I really have to think. Not only should I multiply by 3 to get rid of my denominator, but I should also multiply by a negative to make my negative number into a positive number. So let's multiply everything by a negative 3. The 3's cancel, the negatives cancel. It leaves me with a 1x, which of course you can just write the 1. The y becomes negative, but that's okay. And so does the constant become negative, but again, that's okay as well. So just need that very first letter to be positive and a nice whole number. All right, number 20, we're still dealing with standard form answers. However, because this is multiple choice, we've got two ways to do this. We could do what we've been doing. I could take 2 points. I could write this in slope-intercept form. I could change it. Okay, 2 ways to do this. I'm going to do both because they're actually both equally as easy in my opinion because of the points you have. The first thing I notice with my table is I've got this 0 as an x. That tells me right here I've got a y-intercept. That's going to make my life super easy because I can already get to this point of slope-intercept form. Now I just got to find the slope, which is rise over run. Look what happens as I go up 2 in my rise, as I have a +2 in my rise, my run is +1. That means I've got a slope of 2 over 1. Every time I go up 2, my x values go up 1. A constant rate of change. That was the very first question in this review. So because of how easy the points are in this table, I don't think it's a bad idea to do the question the long way. Subtract the 2x to the other side. Negative 2x plus y equals a negative 8. Now I can multiply everything by a negative 1 to get rid of this negative. And now I have an answer in official standard form, which I can then choose my answer. However, the other way to do this, because I have the multiple choice answers, take my x and y, plug them in. Okay, again, you guys know I don't like using my calculator, but there are times when your calculator makes things really easy. I'm typing this exact thing in, x, which here x is 0, minus 2 times y, y is negative 8, because I used this point. When I hit enter, I should get a negative 8. I didn't, which means A is wrong. Then I go to letter B. I have a 2 times x, x is 0, minus y, y is a negative 8. When I hit enter, I should get 8. I did. That doesn't mean I have my answer. I've got to check all these other points. But my calculator's doing all the work. That's why I don't mind doing this method. Look, as I plugged in my next point as I was talking, I got positive 8. I go to the next one still. I just got to keep going through the table. I don't mind doing this, though, because this is easy to do. I'm just using my calculator. I'm making my calculator do the work. Okay? And what notice is they all equal 8 every single time I plugged it in. So I know B's the answer. Those are the 2 ways to do it. I don't know, some of you might have thought what I called the long way was easier anyways, and so you just do it that way. Everybody's different, but you have 2 very different, and both are appropriate based on the situation. 2 different methods that are both appropriate. So hopefully you've done at least one of those methods before. I wouldn't be surprised if you've talked about both in your class. All right, now we start a couple of graphing questions. Okay, we go a while here with some graphing questions. So I'm going to look to knock these out pretty quick. Okay, we go all the way to 29 with a bunch of graphs. So that's the next 9 questions. All right, so let's start graphing. Point slope form first. Point slope, remember, I can easily see the slope, and hopefully I can find the point. Now, I always tell my students, there's a little trick here. Take the opposite of what you see. I see a -4, that means my x value is 4. I see a +3, that means my y value is -3. Remember, x goes with the x, and y goes with the y. If you're good at that, this is easy to do. I found my point, 1, 2, 3, 4, -1, 2, 3. My slope of -3 over 2 tells me to go down 3 to the right 2. You only need 2 points to make any straight line. Remember, we're not allowed to use rulers, so we use the side of our calculator, and we got our straight line there. So if you're good at point slope form, look at how easy that question was. Now, the reason, I'll just explain this once, the reason why I did that whole opposite thing, remember what your formula has. Your formula has negative signs already, which is why I look at the opposite of the value they give me, because of those negative signs in our formula. Okay? In some formulas, you have plus signs. And so you don't even have to worry about that whole opposite nonsense, okay? But because point slope form has negative signs, it's the easiest way to think about it. Take the opposite of what you see, right? Because technically, what would I be subtracting from y to get a +3? Well, I would be subtracting a negative, right? When I subtract a negative number, that's the same thing as adding that value. Okay, so hopefully that helps. But the trick I tell my students, take the opposite of what you see. You see a -4, make it a positive. That's the opposite. You see a +3, make it a -3. That's the opposite. Okay? All right. Now we're going to start to go really quick because point slope's the hardest one. Slope intercept. Start with my y-intercept. 1, 2, 3, 4, 5. My slope, make it a fraction if you need to. That's a rise of 4 over 1. You only need 2 points to make any line. I'm going to do my best here. The newer calculators, they're definitely easier to make lines with. I apologize, that line I know is a little off the points, but you have the idea. All right. We definitely have a standard form line coming up here soon. Doesn't look, not yet. Which equation matches the graph? All right, my y-intercept is 0. That's why there are no y-intercepts here. My slope is down to the right. Down to the right. That means my slope is negative, which means it's not C or D. Do I go down 1, right 1, or do I go down 2, right 1? Well, down 1, right 1. Down 1, right 1. Down 1, right 1. So it looks like I have that nice negative slope. That's got to be letter B. Number 24, graph that line. Remember, we talked about this earlier in this review. Just a y. That means I go to where y is 3, and I'm going to make a horizontal line. If it's just a y, horizontal. Just an x, vertical. A y and x, that's when I get my diagonal line. Which equation matches that? Well, look at that. We just talked about that. That's a vertical line. That means it's got to be x only, so it's not C or D. Where is x at? X is very clearly at +2. I get my answer. All right, here we go. Here's the one I was talking about. We knew it was coming up. Standard form. You're going to have to graph all 3 forms. Okay. Now, some forms you graph more than others, but you're going to have to graph all 3 forms. So just keep that in mind. Standard form, there are actually 2 ways to do this. So some people just like, they're just like machines. They just like going step by step every single time. Subtract that. Sorry, that shouldn't be negative. Subtract the 4x to the other side. Get y by itself by dividing by the 3. And now I have a slope-intercept equation. That's easy to graph. Okay. And you can do that. But if you're good, like I always separate my students, not by dumb and smart. I think that's silly. A lot of students think that teachers do that. Not at all. In math, what I do is you have students who are good at mental math, and you have students who like to show their work. When I was in high school, I showed my work for every step. As I've started to teach math and I continue to learn math, that's when I started to get good at mental math. A lot of students are surprised at what I can do in my head. It's just because I've done math for so long, okay? I was not always a mental math person. But I know there's a lot of people who at this stage are already very good at mental math. Some of you are looking at this and you realize 4 is a factor of 12, 3 is a factor of 12. This is easy to solve. The reason why it's easy to solve is because I can easily find my x and y intercepts. Because the x-intercept always has 0 as its y value, and the y-intercept always has 0 as its x value. Zeros are easy to work with in math, especially in mental math. If y is 0, that makes this disappear. So 4 times what equals 12? Well, 4 times 3 equals 12. So if y is 0, that gives me the x-intercept 3, 0. If y is 0, if x is 0, that pretty much means that disappears. So 3 times what is 12? Well, 3 times 4 is 12. Easy to figure out. And what's super nice about having intercepts, that's 2 points, and those points are easy to graph. 0, 4, 3, 0. I got my 2 points. I can make my line. So, standard form is tricky. That doesn't always work either. I might have a line that looks like this, and 5 doesn't go into 13, nor does 2, and so now this might not work as nicely. It all depends, but that's where I say, like, my mental math students, you guys see that easily. If you like this trick, use it. Go for it, okay? Definitely, it makes sense. Your teachers will understand it, okay? It makes sense. All right, 3 more graphs really quick here. Number 27. Standard form. This is one where I think it's easier to do slope-intercept. Why? One step. Just add that 3x to the other side. Now I'm very easily in slope-intercept form. Rise 1, 2, 3 to the right 1. I have my 2 points. I make my line. Good to go. Number 28 is kind of like a tricky question. You got to think a little bit. Graph whose slope is negative, y-intercept is positive. But it can be anything. All right, so a positive y-intercept is somewhere up here. A negative slope means I go down to the right. They just wanted me to graph a line, just make a rough sketch of a line. That's definitely a rough sketch of a line with a positive y-intercept and a negative slope. 29 is a little bit more specific. Whose y-intercept is 5, 1, 2, 3, 4, 5, and whose x-intercept is negative 3, negative 1, negative 2, negative 3. So you need to have those specific values. In number 28, you might have a different question or different answer than I have. For 29, you should have the same answer. Hopefully your line's a little bit better than mine. All right, again, I told you guys this was going to be a long video. Just like in the Unit 1 review, I told you guys, skip around, go to whichever questions you need, okay? So hopefully you did that here. But if number 30 is one of the questions you need, then let's look at this one, right? I am, and I don't know how many other people are like me, but I like to do things, like I just told you guys, I like to write everything out. I was very much by the book. When I learn stuff and when I teach stuff, I try to make everything make sense. When I have a less than sign, we learned last chapter, less than signs meant open circles. I still do that with these. So if your teacher didn't tell you about that, that's all right. But this is just my preference, and I have my students do so because, and I taught them, and we'll talk about it maybe in either B or C, but technically that is not an answer. So it should be an open circle. Rise over run, up 1 to the right 3. It's the same reason why, guys, you use a dotted line for these. So I go here, draw my line, right? Remember with less than, you draw dotted lines. So, dotted lines, open circles, they go together. Again, it's just something I do. If your teacher didn't tell you that, you don't have to start doing it all of a sudden, but maybe talk to them about it. All right, less than this line is underneath it. So remember, with inequalities, we have a shaded region. Okay, all inequalities have shaded regions. Less than is below, greater than is above. As your line starts to get more and more horizontal, it's easy to tell what is above and what is below. As that line starts to get more and more vertical, it's a little bit trickier. So there are definitely some tricks to do with that. One is to move the pen like I'm doing right now. If I have a line that is quite vertical, something like this, that's tough to tell sometimes what's less than or what's above it or below it. So what I like to do is I tilt it and I twist it based on that y-intercept. So okay, y-intercept's right here. So I twist my pen until I hit a point where I'm comfortable saying, oh, okay, I know less than is down here. And now I put the pen back, and now I know, okay, this is the side I should shade. So that's one trick. My other trick is I tell people use that y-intercept to your advantage. If this line would be something like y is less than big slope, let's say 5x minus 3, right? Use your y-intercept to your advantage. Y is less than negative 3. Where are your y values less than negative 3? Well, for example, negative 4, negative 5, negative 6, these numbers. So that's another trick that I use. And lots of different tricks. You can plug in a random point. A lot of people like to try the point 0, 0. And the reason why they do that is why we're doing B and C, right? To be a solution, you should be in the shaded region. So how could you answer letter B? Explain how to use your graph. No math work. How could you use your graph to explain whether 3, negative 2? Well, I would plot the point 3, negative 2. And what I would notice is 3, negative 2 is in the shaded region. So yes, it is a solution. And the reason is because it is plotted in the shaded region. That's how I know it's an answer. So going back to what we were doing with this like made up question over here, plug in a point. So 0, 0 is an easy point to deal with. When we were talking about mental math a couple of pages ago, right? 0, 0, math is super easy. Is 0 less than negative 3? Again, I got the 0 because I plugged the 0 in for y. I plugged the 0 in for x. 5 times 0 is 0. 0 minus 3 is minus 3. So I jumped right to here after plugging in 0, 0. Is this true? Is 0 less than negative 3? No, it's not true, which means this is not a solution, which means I need to shade the other side because the shaded region is your possible solutions. So 3 different ways I teach my students how to decide which way to graph. And again, the fourth way is, some of you are just good at this. When I have a line that's pretty horizontal, it's obvious to tell this is less than the line, this is greater than the line. So as that line starts to get more and more horizontal, it's easier to tell. But when it's straight up and down, it's not as easy. Now, letter C says use algebra. Well, to use algebra, I would take this and I would plug it back in. Kind of like I did with 0, 0 over here. So I plug in the 3 for x. I plug in the negative 2 for y, and I do some math. Well, 1/3 times 3 is 1. 1 plus 1 is 2. Is negative 2 less than 2? Yes, that's true. So 3, negative 2 is a solution. Okay, so we backed it up both ways. We used algebra, we used our graph. All right, function notation, something we talked about in this section as well. Big thing again for those pre-calcs and calc classes is something you're going to get used to. Function notation, just a fancy way to write some things, and allows me to find inputs and outputs pretty easily. I have this negative 6, that's my input, so let's plug a negative 6 in here. Negative 2 times negative 6 plus 5. Well, the negative times negative would be a positive 12 plus 5 is 17. Plugging in 0 is easier to do. Plug in that 0. Negative 2 times 0 is 0. 0 plus 5 is 5. Plug in the 6 here. Negative 2 times 6 is a negative 12. Negative 12 plus 5 is a negative 7. Plug in the 10. Negative 2 times 10 plus 5. And what it said, what you see is you get negative 15. And that's what they told you. They said, what does that mean? Well, a couple of things. First of all, when x is 10, that means y is negative 15. Another way to say that is when the input is 10, the output's negative 15. But what it could also mean is the point 10, negative 15 is on the line. And when I put that input in, I get that output. That's a point, x, y. That's a point on that line. All right, long video. I know, we're almost done. 2 pages. If you've been following along the whole time, this has been a heck of a study session. Hopefully this is reviewing things you're going to do well on your test. All right. 32. In order for a relation to be a function, which variable is not allowed to repeat? Well, good thing we never talked about G or C in this class, right? We talked about variables x and y, but which one can't repeat? The x value can't repeat. Here's another question to look at that, right? If I have a function below, most times you can assume inputs on the left, outputs on the right. Look at this. Input is the same thing as x. Output's the same thing as y. Do I have any x's that repeated? Well, yeah, this x, 1, goes with 4, and it also goes with 5. That's almost like if I were to write this out, I'd have the point 1, 4, 1, 5. My x values repeating. Is the relation shown below a function? No. X repeated. So we have that repeated x value. You can't have that by a function. It's just some fancy thing that we use a lot in math, especially high-level math. That it's an easy topic here that we'll expand on down the road. Functions, okay? Input, output, domain, and range, and talking about whether or not something's a function. X can't repeat. So if x can't repeat, to do a question like number 34, draw a vertical line, the vertical line test, because vertical lines, these x values are repeating, right? All of these x values are the same. So if I draw a vertical line and it touches the function twice, that means that x value repeated. So the x value, negative 1, negative 2, negative 3, is on this graph twice, not a function, because x value repeated. But it's easier to tell. You just draw those vertical lines. Last page. Here we go. This is the longest video review of the year. So we're almost done. Given the set of ordered pairs, state the domain and range. Remember, domain is all of your x values, and when you can list them all, you should list them all. So this is a fun exercise, right? Look at that. We got 1, 2, 3, 4, 5, all of my x values. Range, all of my y values. Negative 7, negative 4, negative 1, 2, 5. Didn't happen here, but if you ever have any range values that are the same, you don't have to write it twice. You can, but you don't have to. Okay? When you can't list the entire domain and range, we have a different way to write that. And depending on your teacher, you might have learned 2 different ways to write that. Okay? I call them interval notation and inequality notation. And what I told my students is, honestly, inequality notation is like a, I don't mean this in a rude way, but it's kind of like a little kid way to write it, and interval notation is like a big kid. Like you're more mature. Your math skills are more refined when you write it in interval notation. Neither is wrong, neither is bad. I'll accept either in algebra. I'm sure all teachers would accept either in algebra. But as you start to get in higher level classes, you might start to go towards one way or the other. It also really does come down to a preference. But I think you should know both, in my opinion. You should be able to go back and forth between the two. Either way, domain is X. So as I start with my interval notation, I need to let people know, okay, we're looking at the domain here. Domain is X, which goes left to right. And I always kind of do that for my students. I kind of write those things. Domain X, X is left to right. How far left does this graph go? It looks like it goes as far as -1. And it looks like -1 is on the graph, so I'm going to include that by using a bracket. If you've never done this before, you can kind of tune me out until I get to inequality notation. How far does my domain go to the right? Well, it includes all of those points all the way until we get to the right side of the circle, which is at 1, 2, 3, 4, 5. And 5 also seems to be on the circle, so I'm going to include it with that bracket. Then we go to range, which is the y value. Range goes up and down. What's the lowest value on this graph? Seems to be down here at -2, also included on the picture, so I'll use that square bracket. Highest value seems to be at 4, also seems to be included on the picture. What I mean by that is I could make a point which would have a y value of 4, so I include that. If you don't, because it didn't happen here, but if you wanted to use this notation, if you don't include a value, then you use parentheses. Parentheses mean I could get really close to that value, but I can't include it. Inequality notation, you don't need the D and R because you use the X and Y, and you write it like a compound inequality, like we did last chapter, which is why we talked about it last chapter. The endpoints are still going to be the same, and I'm going to use that less than or equal to sign here because I'm including these values. Same thing with my range, I'm including those values. But that's how some of you probably wrote your domain and range. All right, that takes us to the end. I know that didn't go into as much detail on every single topic, so you might have to look things up. You still might have to talk to your teacher, but hopefully I was able to review most of the things. So thanks for sticking with if you watched the whole video.